A continuación, vamos a hacer la presentación de Arlen Nipper. Arlen es, como comenté anteriormente, uno de los coinventores de la tecnología MQTT y es a su vez el presidente de Cirrus Link. Muchas gracias, Arlen. Bienvenido.
Thank you very much. Well, thank you, everybody. Again, my name's Arlen Nipper, and hopefully what I can do is take all of the information that you've heard from B&B SmartWorks, Advantech, the introduction that Antonio gave, along with the very good review of the Ignition industrial platform, to bring this all together and how we're using in Ignition and IIoT for successful use cases. Now, the first thing I'm going to start with is a background of what are we talking about. I know that everybody has, you know, all of the pundits of IIoT and all of the promise, but why are we looking at this from all of a sudden? What changed with the acronym SCADA that we've been doing for the last 35 years, and now why is the name SCADA moved to IIoT? Well, first of all, I think for a large extent, we have been acquiring data and we've been pulling it into operational systems. But the promise now with cloud services platforms and IT services that we can get is that if we could get more of the information that we have stranded today in our operational systems and in our devices, then there's the promise of new technology like machine learning and predictive analytics and being able to run diagnostics remotely and being able to watch instrumentation 24/7 and take more advantage of the smart instruments that we have in the field. But to a large extent, a lot of the product offerings that I see, literally, they've taken the word SCADA and they've erased it and they've replaced that word with IIoT. But then when you look down one level, you look at it and you say, oh, well, we're still doing the same thing. And what's the problem with our current implementations is that we are taking all of these smart devices that we're putting in the field, PLCs, RTUs, smart transmitters, cell automation in the factory. And what's the first thing we do? We tightly couple those devices to an application with a protocol. Now, 15, 20 years ago, the IT world already figured out that they needed to quit writing applications that were hard-coded to other applications. Because anytime you wanted to do something different, you had to rewrite all of the applications that were hard-coded. But yet, for the last 35 years, 40 years, in the industrial space, we've been tightly coupling our devices to our applications, to our SCADA applications. And that means that when we want to expand, when we have a new idea, when we want to try something new, then we're having to go to the operations department and say, please, Mr. Operations Manager, can you poll for some more information that I know you're not interested in, but since you're connected to my devices in the field, you're going to have to poll for information that you don't need to pull it through your SCADA system to provide it to another application. So, for 35 years, we've been taking perfectly good SCADA systems, and then we try to make them look like middleware-oriented software. So maybe the first thought that we have here, and really the 2 points that I'm going to cover in everything around MQTT, it's all about providing technology that lets us think differently about SCADA. Let's connect devices to infrastructure, not to applications. Now, once we have those devices connected to infrastructure, now we can look in the whole world and look for best-in-class applications that can plug into that infrastructure and take advantage of it. But we're not constrained to a single application. Now, the second step is you better be able to demonstrate that this new architecture, this new modern architecture, is a superior OT solution from a mission-critical real-time standpoint than a legacy approach. As in the introduction, I had the great opportunity to work with Andy Stanford Clark, who was with IBM, and Andy and I were able to invent MQTT. And The reason we did that is actually on a pipeline project for Phillips 66. We had constrained bandwidth over VSAT. They wanted to bring more information in quicker. So we had to use that architecture to literally create a solution for a mission-critical real-time operational system. Now, having said that, for 15 years prior to starting Cirrus Link, I can tell you that the IT down to OT approach doesn't work. So what Ignition and inductive automation and Cirrus Link's approach is we should enable OT. We should enable the operations technology and the SCADA managers to put in technology that then we can enable OT to push all of this operations up to IT. And until we can get to that point, we're never going to get to the full realization of what we can do with the industrial Internet of Things. Now, having said that, Cirrus Link does a lot of consulting with a lot of companies to help them put together migration strategies. In other words, how I'm caught in a cycle. I'm trying to upgrade my system, but I can't upgrade it because my SCADA system doesn't talk this protocol, or this new sensor that I want to buy doesn't talk the protocol that my SCADA system talks. So how can I put a migration strategy in? So we look at, we talk with the operations department, we talk with line of business people, and we see what is the intent? What do you really want to do with this data? And then we try to start putting together a migration strategy. Now, having said that, we look out there, and a lot of the legacy implementations are very hard and very complex and very rigid and hard to upgrade. And we've got this problem in the industry is that everybody is concerned about the aging workforce. What's going to happen when the 50-year-old, 55-year-old SCADA engineers migrate out of the industry? Then how are we going to teach the people coming in, the new graduates coming into the industry, how our automation systems work? Now, I'll put that in context in that today, due to the wide availability of MQTT and all the technology that's out there, if I had the graduating class of the 2017 computer engineers, electrical engineers, and data scientists, and I put them all in the room in front of me, and if I interviewed them, I said, how many of you engineers already are familiar with OPCUA or Modbus or Allen Bradley DF1 or Modbus protocol or HART protocol or Omron NJ protocol? Raise your hands. And probably very few of them would already know that technology. So here they are, they're coming into our industry, and we're giving them 40-year-old tools to work with. But if I ask that same graduating class, how many of you students already have a Raspberry Pi in your dorm room and you're using MQTT and Node-RED to turn things on and off, and you already know how this technology works? And I'll bet you just about every engineer would raise their hands. They are familiar with this technology. So what we're talking about is taking this widely available, easy to understand technology and making it applicable to real-time mission-critical operational systems. This is a survey result. The Eclipse Software Foundation has been surveying IoT solution developers for the last 6 years. This is the results of the 2017 survey, and this is across consumer, industrial, and commercial markets. You can see here that already MQTT across all of those markets has almost a 55% share of what's being designed for future products. Now, if we take a look at that survey result and we take out the consumer and the commercial side of it and look at just industrial, then you have to understand that HTTP and COAP are both stateless protocols. So they're great for a web interface to configure things, to monitor things, but there's no way that you could use a stateless protocol for mission-critical real-time SCADA. So if we look at it in just the industrial market, MQTT would have a very large majority of all of the IoT and IIoT products and solutions that are being developed today. Now, one of the advantages of MQTT is it's very, very simple. I'll put this in contrast, is that you can download the entire MQTT specification from the OASIS standards body, and you'll see it's about 70 pages long. And then I kind of compare MQTT to Modbus. Modbus has been around for 40 years. It's still the most used industrial protocol today. And a large reason is that it's very simple to implement, it's very easy to debug, it's very easy to understand. So MQTT is the same thing, and if we compared that to something, let's say like OPC-UA, if you downloaded the entire specification, it's about 4,000 pages long. So I think what's going to happen is that because of its simplicity, because of the fact that it can run on minimal hardware in the field, MQTT will continue to be adopted by a large portion of the OEM device manufacturers like Advantech, B&B, that just presented their product topologies. Now, one of the things that the great thing about MQTT is it's very open. It's completely, you can publish anything that you want on any topic with any payload that you want. So what we realized in working with inductive automation and integrators and the end customers is that we needed to take the 20 years of experience that all of the Cirrus Link developers had in creating industrial solutions using MQTT and sit down and document best practices, lessons learned, what not to do, and come up with a specification that says, if we're going to use MQTT in a real-time mission-critical environment, this is probably a good way to do it. And so we call this the specification spark plug. And in there, we define a topic namespace that's applicable for the industrial industry. We define, in keeping with the original intent of MQTT, which was very lightweight, very high speed, low latency, low bandwidth, we defined a binary MQTT payload. Now, we know that there's a lot of MQTT applications out there today publishing and subscribing on data, but they're using JSON or XML formats, which we just cannot afford over cellular, radio, VSAT network topologies. And lastly, we defined how do you manage state with MQTT? What does state mean in a real-time SCADA system, and how does Ignition use that state to let you know in real time the state of all your tags and all your devices in your entire network? Now, we did that, and once we had done the specification, we did reference implementation code in C, Java, JavaScript, Python, and Node-RED. And then we made the entire specification and all of the reference implementation code free to anybody that wants to download it and implement it. Now, what I'm going to do here is go through what does, when everybody's talking about MQTT, I thought I'd go just a little bit low level here and just show what are the components that you need and how do they work. So for an MQTT infrastructure, you need an MQTT server and an MQTT client. And a client can establish, now the first thing that's very disruptive here, remember the first thing that we said in the start of this presentation, is we're going to connect devices to infrastructure, not to applications. So what's happened here that's very disruptive in the SCADA world is our client, our devices in the field and our applications are making a remote originated MQTT connection. So we have no application in the center that's making outbound connections. Now, once we've created that MQTT, that TCP/IP connection, we create an MQTT session. We connect and we create a session. Now, in that session, we provide a username and password and a last will and testament. So you understand username, you understand password, but Arlen, what is the last will and testament? Well, the last will and testament is a message that the MQTT client provides to the MQTT server. And it says that if I die, if my cellular network goes off, if my satellite network goes down, if somebody cuts my Ethernet cable, the MQTT server is going to publish my death certificate on that connection loss. And that's how we maintain real-time state in an MQTT-based infrastructure. So we make our socket connection, we create our MQTT session, and now notice that we can publish any information that anybody in the enterprise is interested in. Yes, we can publish real-time process variables from registers and PLCs, but we can also publish diagnostics. We can publish configuration information. We can publish metrics on how well our wireless network is working or how well our Ethernet network is working. So all of a sudden, now, so we can publish the operational data that satisfies all of the OT requirements, but now we're able to look at more of that data that we're currently leaving stranded in the field that's not required by operations, so that other consumers in the enterprise can subscribe to and get that information in real time. And the last thing that we do is we subscribe to information that we're interested in. Now, at this point in time, this isn't a very interesting infrastructure, but if we were to add Ignition and it subscribed to everything that we were publishing, then now we can see how this infrastructure starts to go together. But notice that if that application goes away, we're connecting devices to infrastructure, and therefore the information is still flowing. So now we can add applications that subscribe, other applications that publish other interesting data, and ultimately the result is we've created a message-oriented middleware infrastructure that provides one-to-many data relationships with real-time connection monitoring, which gives us a state-of-the-art decoupled SCADA system. Now, let's see how that all goes together. So let's go back and let's say, remember, what we're going to do is we're going to connect devices to infrastructure. So let's do that right now. Now, all of these OEM manufacturers on the right, B&B, Alexis, Hilscher, Magnetrol, Moxa, Opto22, a Raspberry Pi, an embedded computer running Ignition Edge like an Advantech Uno, or even an Ignition Gateway, could all be considered edge of network devices, and they have all created a remote originated connection into an infrastructure. Yes, MQTT uses TCP IP natively, so we can use technologies like TLS to provide us best-in-class authentication and encryption. And we can put our MQTT servers in a DMZ. So at this point in time, we have a very unique system in that we have no one application here in the center that's making outbound connections through firewalls, through all kinds of network interfaces. We have a very easy to manage single point of configuration for applications and devices that want to connect into our infrastructure. Now, the next step we said is provide a superior OT solution. And that's where we get to take the Ignition Gateway along with the MQTT engine module and literally plug it into the infrastructure. And because of the spark plug specification that I mentioned previously, not only can it do that, that means it can learn automatically all the devices in the infrastructure and all of their tags automatically. So for example, when we plug into very large infrastructures with hundreds of thousands of tags that are already using MQTT, we can literally discover every tag in the infrastructure in under 10 seconds and have those populated. Now, at this point in time, we met our goals. We could stop, we could go home, we could show the operational managers, the SCADA engineers, that they now have a better, faster, more scalable, more reliable, more available SCADA solution than what they had. But now that we have this architecture, it gets very interesting in that now we could plug in another SCADA system. We could plug test and development, and it could be watching production data. So one of the advantages of using MQTT architectures is that you've eliminated cutovers in the future. So instead of bringing down one SCADA application and bringing up the next version and hoping that everything comes up, we can run as long as we want to in test and development, get everything checked out, get all of our point checks, and then we can just migrate over one console, one dashboard at a time as we get everything proved out. Now, once we have this infrastructure, again, everything is decoupled, so we can start looking at best-in-class applications that might want to plug into that infrastructure and subscribe to that information. Now, notice that the SCADA system now is not a bottleneck. It's not the thing in the middle that's connected to the devices that we have to pull that information through to get to other best-in-class applications. We can add transmission to our ignition gateway, and that would let us publish any existing OPC tags, existing memory tags, existing calculation tags into our infrastructure. And we could use a tool like Kafka and NiFi to be able to subscribe to all of our MES data or all of our OEE data that we wanted to bring into those applications. Once we've got this infrastructure, we can look at things like Azure, IBM Bluemix, AWS IIoT, and now, only now, do we have our OT infrastructure set up so that now we can start looking at some of the promise of what cloud computing and big data. So we can look and play with things like machine learning, predictive analytics, and all of the promise that the reason that we're talking about the industrial Internet of Things. Now, lastly, I'll just show two new modules that Cirrus Link will be coming out with in September at the Inductive Community Conference. We'll have a module that can plug into Ignition. It's called AWS Injector, and that will let us take any tag that's in our Ignition system and publish and take those tags directly into Amazon Kinesis in real time, and or take any of those tags into Azure IoT Hub as well. Now, what I'm going to do now is I'm going to actually show you all of this working, and then we'll go through some actual use cases. So what I'm going to do is Maria already did a fantastic demonstration of Ignition, and I'm literally going to open my Ignition console here. And I will just let everybody know, my dashboards aren't nearly as pretty as Maria's, but I guess since I'm not in the business of building dashboards, then mine are more functional. We'll put it that way. So notice here that our designer, just like Maria was showing you, it doesn't change. It's all the same. The only thing that's different is that we now have a tag provider called MQTT Engine. And before we get into looking at the connectivity to the edge devices and the PLCs and all of our process variables, let's actually look at what we can do with the infrastructure information. So in my diagram, I showed you that I had 3 MQTT servers in my infrastructure. And because in Ignition, all tags we can have as many tags as we want. So MQTT Engine builds out a lot of metric information that we can use. So I can see here that all of my MQTT servers are online. I can measure my latency in milliseconds from my MQTT servers into my Ignition gateway. And so now I can build out a dashboard that starts showing me what my network actually looks like. So you can see here that I can tell you in real time that I have 33 PLCs connected. None of them are offline. I have 12 edge of network devices, and I have 3 MQTT servers that are online and available in my infrastructure. So now if we take a look at the ecosystem of device manufacturers and look at our tags again, we see here we can go up to our edge nodes, and we have folders for all of these devices. So let's go to the IA group to Advantech Uno with an Atom 6060 module, and notice that all of those tags are available. And we can actually control those from here. So I can literally on an Atom, and I'll pull up a Atom Uno dashboard using these tags. And I can turn pump 1 control off. I can turn it back on. Now I've got my Atom 6060 that's connected to my Uno that's running Ignition Edge. It's got one of the inputs is set up as a counter. So I've got my pump cycle count here. So as I click through that, you'll see that that changes in real time. Now notice that one of the advantages of MQTT, remember we said that what we're doing is we're trying to optimize our bandwidth. So right now, I know that I'm online. I know that that UNO, the pump 1 is off, but notice this is my number of bytes that I'm transmitting over the network is 0. So we're literally, at this point in time, we've done 100% bandwidth reduction, but yet we're polling at 100 millisecond rate. But as soon as something changes, that change gets published, and we see bytes come across the network. So that's one of the huge advantages of MQTT. Now, also realize is that there could be 10 or 100 other applications all subscribed to this information that the UNO is publishing in addition to Ignition. Now, one of the big advantages using Sparkplug is, as I said, the ability to automatically discover infrastructure. So I asked the question here is, what would happen if I put 200 additional PLCs on the network? How quickly could I discover those and have those all populated and all of the tags in Ignition? So we're going to go to one other view. And this view is, I call it my Internet of Things view of the world. And what this is that each green square represents a fully discovered device in Ignition. Now, what we've had to do with our very large customers is we've had to create what we call a swarm simulator that lets us simulate very large numbers of devices in the field. And so what I'm going to do is I'm going to put one of these edge devices online right now. And you can see it's connected to my MQTT server number 1. But let's see what happened in Ignition. Notice there's no folders here called Swarm, so I'm going to refresh this folder. And now we have a folder called Swarm 1. And in there, it's an edge of network device. And we have 2 fully discovered Modbus PLCs with tags updating twice a second. So with that, and that was automatically discovered. We didn't have to go into Ignition. We didn't have to drag tags from our OPC UA server. We didn't have to rename those tags. Everything was self-discovered. So now let's see what happens when we put 200 of those devices online. I'm going to put them online now. And every time another green square appears, that is another device that's been fully discovered and recognized in Ignition. So now we have 150 PLCs. Now we have 175 PLCs. And now we have our 231. So we just added 200 PLCs to our Ignition infrastructure. Let's take a look at our tag browser again. And notice we refresh this folder. Now we have 200 PLCs with all of their registers defined, with all of the data updating twice a second. So that is, as you look at this, and remember, we'll go back to the presentation now. What I'm showing is that this combination of all of these OEM devices on the right and all of these applications and cloud services now have visibility of every one of those 231 PLCs that I just automatically discovered within Ignition. So literally, you could have this infrastructure set up and plug into it and discover all of those tags and never have to edit any of those tags. And one of the things that we're really promoting here is that the kind of the third part of this is we have to connect our devices to infrastructure instead of to applications. We have to provide a superior OT solution. And the third thing is that our devices should start becoming the tag authority. One of the biggest problems I see that Cirrus Link sees in helping customers migrate from legacy SCADA systems is that they're trying to figure out what their tags are in the field. because they're having to hand enter those tags. And I don't want to have all of these other applications. I have to go in and edit a tag and say, oh, well, this tag is an integer, or this tag is a floating point, or this tag is a string. No, I want the applications to be able to discover that automatically as they connect to the infrastructure. So having said that, and seeing how this kind of all goes together, we'll go through some interesting use cases in where we use this technology. Again, our primary market, and the reason that MQTT was invented 20 years ago was for the oil and gas market, where we had lots of remote connected devices and customers were wanting to bring in more information over limited networks. They were wanting to detect status changes quicker in the field. So we were able to go from, maybe 5 minutes or 3 minutes polling cycles to where we can guarantee that any state change in the field will be reflected over a VSAT system in less than 5 seconds, no matter how many nodes you've got in your network. So one of the opportunities came up was an IoT project for the food industry. In other words, they already had ignition gateways out in the field, but they wanted to take some of those tags and be able to bring them in very, very quickly so they could do reporting on the efficient use of water and power in their plants that were remotely located. So they needed to be able to have connectivity to Modbus I/O. It needed to be securely deployable behind firewalls so that it minimized the effect of the IT networks. It needed to be easy to integrate with their business, and it needed to be cost effective. And so what they did was they looked at the fact that they could put MQTT transmission into an existing ignition gateway, pick up all of their Modbus I/O, and just publish it to an MQTT server. Now, before I showed you that NiFi and Kafka are technologies that a lot of our ignition customers are looking at and using today, and NiFi and Kafka happen to be natively enabled to connect to and consume MQTT, subscribe to MQTT messages. And so what we did was we added the OPC-UA driver for Modbus. It polled, got the water information, and just published that to an MQTT server. And at corporate, they added a NiFi flow that would subscribe to that information and then pushed it into Kafka so that they could run their EMR, Elastic MapReduce, for the Hadoop applications. So what we're able to do was again, since MQTT is a remote originated connection, we have no ports open in the field. So from an IT security standpoint, that was fantastic. Didn't have to open any inbound firewalls. Using TLS security means that we could provide the level of authentication and encryption that we needed. And really, IT didn't need to be involved hardly ever at any of the remote plants. NiFi was already MQTT enabled, so it was able to subscribe to the spark plug messages being published. And it was easy to deploy, since we could deploy it out in all of the field locations. So it ended up being a cost-effective. It minimized the amount of hardware and software development. It was almost just a plug-in. And now they can do everything that they want using the MQTT transmission module. We had another customer that, again, was already using Ignition, an electric power utility, and they needed to monitor the fast deployment of solar farms and be able to look at that information. This is a good example where not only did the control center need that information for a centralized SCADA, they also wanted to use it as a BI tool for their corporate data center. So it needed to connect to local Allen Bradleys and provide a local HMI. Again, we had the data security aspects, and to be able to push that data to the corporate data center using MQTT, and again, it had to be cost effective. So what we ended up with is, again, at the remote sites, at each remote site, we had an ignition gateway running MQTT transmission. So as the information came in from the Allen Bradley PLCs for the local display, it was also being published in real time at the same time to an MQTT server. Now from there, the corporate data center could subscribe to that information, as well as the control center itself. So again, this is my example in the topology that I showed, showing multiple SCADA systems running in parallel, looking at subsets of the overall MQTT messages that are being published. So again, this is an overview of that solution. And we were able, again, we provided the connectivity to the Allen Bradley PLCs with the local Ignition OPC-UA server. We passed all of their security requirements using MQTT and the fact that it was remote originated connection. And we were able to have multiple data consumers of the information that we were publishing. And actually 3. So we had the local display was consuming that information, as well as the control center, as well as the corporate data center. We had another application where we had a food equipment company. This company makes very large blenders and mixers and bakers for the food industry. And one of the problems is that they were having trouble doing remote management of their equipment. So if a customer called and he had a problem, they needed visibility into the process. What's wrong with that machine? So we needed, again, to connect to their local Allen Bradley PLCs. Again, be able to show that you didn't need a lot of IT expertise out at these bakeries and remote locations that this equipment was going on to, and provide a cloud infrastructure they could connect to. So we used Ignition Edge along with MQTT, and then we had a centralized MQTT Chariot server, and then they installed Ignition on AWS, and that becomes their machine monitoring solution for machines that are going all over the world. Again, easy connectivity out of the remote sites, have a centralized MQTT server with redundancy, and then all of that going into an Ignition gateway running on Amazon EC2 instance. Again, so from a product's requirement check, we were able to completely install MQTT server. So that is already going to give us the ability to manage thousands, if not tens of thousands of assets, connect to all of their PLCs that are local in the remote site, again, providing the security that MQTT provides. And in this particular instance, being able to deploy it on the cloud and show a cost-effective solution. And the final one we'll give here is, I know that people were talking about OEE, and this was for a global automotive part manufacturer who wanted, again, to get information in real time for their OEE. So they needed to connect to all the local I/O and be able to bring that into both a regional as well as a corporate data center. So the topology they ended up with, again, was Ignition Edge and Ignition Gateways running actually at the plant facilities. And they're publishing it using MQTT transmission to a Cirrus Link Chariot MQTT server. And from there, they could go to their regional centers. And not only were they able to do that, they were able to do it with primary and hot standby redundancy across the entire infrastructure. So that's the end of my presentation. And in summary, I just kind of want to review what we talked about. MQTT in and of itself is an interesting technology, but it's really how do we apply MQTT, how do we take advantage of it, and really go to the next level and almost make that transparent. The thing that we're really talking about here is connecting devices to infrastructure, applications to infrastructure. And once we can accomplish that, then we've got I call it the serendipitous nature of data, in that in most SCADA systems, the thing that I usually say is that we know what we know and we deploy it. But once we deploy it, it's always those, I didn't know what I didn't know, and now they want other information into other applications. And I think I showed that with inductive automation and the fantastic platform that they've got with Ignition. It really is an industrial application platform. And because it was a platform, Cirrus Link were able to develop the MQTT module technologies that we're dropping into Ignition now. And then also with the work that we've done with the Sparkplug spec and the OEM community and companies like Advantech and B&B, as well as Opto22 and Hilscher and Alexis and Moxa. Now we're starting to have this whole ecosystem of partners with a lot of different tools and a lot of different capabilities that we can bring together all on a common platform. So with that, Antonio, I'll hand it back to you.
Thank you, Arlen. Muchas gracias por esa excelente presentación. Y a continuación voy a transferir la presentación a Fanny Scargill, quien nos va a hacer un resumen de todo lo que hemos visto hasta el momento y todas las posibilidades que hay para Latinoamérica en la alianza BP SmartWorks Inductive Automation.
Y muchas gracias a todos, muy amables, muy importante el mensaje de hoy en día después de esta presentación que fue muy clara y detallada, es poder entender que el IoT hoy en día es una realidad, ya no es una teoría, ya nosotros tenemos la infraestructura y la plataforma que va a permitir que podamos ofrecer estas soluciones completas a todos los clientes en todos los diferentes mercados. La alianza que tenemos hoy en día entre BP SmartWorks en conjunto con Ignition, hacen que esta solución sea completa y que todos ustedes en cualquier momento, en cualquier proyecto, puedan contar con nosotros para presentar esta solución como un ente completo. Ya no por separado, somos una solución completa para que todos puedan entender mejor el concepto y cuando presenten lo que es el concepto de IoT, ya existe en la plataforma. Giovanni, muchísimas gracias.
Perfecto, Fanny, muchas gracias. En este momento ya tenemos algunas preguntas que nos han hecho algunos de los asistentes. Una de esas preguntas es, cuando se tiene un controlador antiguo, ¿cómo podemos integrarlo al IIoT? Esto forma parte más o menos de la presentación que hizo Arlen, en la cual muestra cómo dispositivos conectados remotamente podrían estar conectándose a través de un protocolo conocido industrial como Modbus o cualquiera de los protocolos como Ethernet IP y a través de un convertidor puede integrarse al Internet de las cosas. Arlen, can you tell us how any old controller can be connected to the IIoT? This is a question from one of our attendants.
Okay. Well, again, that was the device ecosystem that I discussed initially. Now, we will be announcing many more partners that have adopted Sparkplug technology at the Inductive Automation Community Conference in September. But I think if you look at the ecosystem that I presented, B&B SmartWorks, Advantech, Alexis, Hilscher, Opto22, Moxa, and you look at any existing brownfield installation where they still have serial. You know, again, I laugh because, you know, some of the young engineers, they don't even know what an RS-232 port is because they don't come out on PCs anymore, right? But yet we have infrastructure in the field that is 35, 40 years old. And so with these devices that I presented, we've got connectivity to existing brownfield applications, whether that be Allen Bradley PLCs, Modbus PLCs, legacy RTUs, just about the whole ecosystem or the whole automation landscape. Anything that's existing out there today, we can provide connectivity with it with edge gateway technology. Now, our ultimate goal is to start bringing vendors in and having them put Sparkplug on natively. And that's what we did with Opto22, and that's what we're doing with other PLC manufacturers now.
Perfecto. Tenemos otra inquietud. Esto es con respecto a BP SmartWorks. La pregunta es, tenemos unos equipos que están ubicados en sitios remotos, pero la comunicación no es tan fiable. ¿Es posible que se pueda tener un almacenamiento local para la transmisión tipo Store and Forward? Esta pregunta la podemos dirigir al equipo de BB SmartWorks.
Preguntando. Sí. Allá. Sí, Giovanni, muchas gracias. Sí, nosotros tenemos la capacidad de poder hacer almacenamiento local en los equipos de nosotros si es necesario, dependiendo de la solución.
Perfecto, Fanny, muchísimas gracias. Por otro lado, también hay otra pregunta. Ignition Edge. En los bordes de red, ¿cómo se instala el Ignition Edge en los bordes de red en el dispositivo? ¿Qué requerimientos debe tener el equipo remoto? Esta pregunta nos la puede de pronto ayudar a responder Arlen. Arlen, Ignition Edge, how it is installed in the network edge, and what are the requirements that we have, that the equipment should be have to integrate this Ignition Edge?
Okay, I will answer that. Ignition Edge is designed to run on pretty much any architecture. So remember, just like Maria stated for Ignition Gateway, it can run on Windows, it can run on Mac, it can run on Linux. The Ignition Edge is the same technology, but designed to run on a much, much smaller footprint device. So really the only requirements for Ignition Edge are an Oracle JVM and an adequate processor. So one of the examples that if you go to the Ignition inductive automation website, click on downloads, you'll see that there's an ARM image for Ignition Edge. And by taking that image, you can load it onto a Raspberry Pi and run Ignition Edge on a Raspberry Pi quite nicely. Now, in the other diagrams that you saw and in the demo that I did, I have an Advantech Uno embedded computer, and that's a small embedded computer from Advantech. And again, it's more than capable of running Ignition Edge. So we have many, many customers. They have their own favorite embedded industrial PC running Ignition Edge, but we haven't found any above the class of a Raspberry Pi compute capability that couldn't run Ignition Edge.
Excellent. Arlen, thank you very much. Muchas gracias, Arlen, por su presentación. Y bueno, hasta el momento, esto es todo lo que hemos querido presentar. No tenemos más preguntas. María, no sé si quieres comentar algo.
No, pues muchas gracias, Antonio, por organizar el webinar. Muchas gracias. Thank you, Arlen, for your time. Gracias, Fanny, y gracias a la gente de BB SmartWorks. Cualquier otra presentación como esta que necesiten de ayuda de parte de nosotros, estamos a la orden. Y nada, muchas gracias por organizarla.
Excelente. Muchísimas gracias también a todo el equipo, a Albeiro, a Fanny, a Arlen, María. Muchas gracias por participar. Estaremos próximamente en el siguiente webinar. Estaremos hablando de control estadístico y de efectividad global de los equipos. Prontamente presentando toda esta información. Muchas gracias y hasta la próxima.
Okay, thank you. Thank you.
Thanks, everybody.
Thank you very much.